Recording is started. It is Friday, September 9th. Here's our agenda. So your guys' homework, I'm going to pick up on Monday. Now remember what the homework was, is there were these 6 projectile scenarios. We actually did 5 of these in class. So as long as you followed along, then we just got one last scenario. Okay. Now on the opposite side of this page are 20 conceptual questions, and we're about to do these on Kahoot. So the Kahoot questions are these questions, right? Okay, guys got this? All right, then I just handed you guys a projectile quiz. You guys have a projectile quiz, like something like this? Did you get one of these? All right, here you go. All right. So let's take a glance at this real fast. Can point out some stuff you guys. Oh, and let's have this due on Tuesday, right? So you guys got a few days. You guys got open notes to take on quiz. Okay. So first question is cannons at the top of a cliff above a plane below. Remember, there are a couple of classic situations that we've been looking at, and one of them looks like this, right? So your guys' first question with the graphs involves this, right? Okay. And I'm asking you guys what height versus time, the vertical component of velocity versus time, and the horizontal component of velocity versus time. In fact, if you look back in your notes, I bet you'll see the answer to that question. Okay, what do those graphs look like? Of course, you should know how to do those, but the answer is in your notes. Okay. Then there's a couple of conceptual questions that, hey, we're about to do the Kahoot. You guys are about to, for sure, be able to get those answers. Okay. You guys got a couple of conceptual questions we're about to do the Kahoot with. Okay. Okay. Then on the back, there is a single scenario, single projectile scenario. It says they came in on a flat terrain, angled up at some angle. Okay. Well, and so there's a couple of classic projectile scenarios that we're doing, like your graphs of all that one. And everybody's question on the back involves a picture of something kind of like this, you know, just different numbers, but so something to do with like a cannon down here on the ground level, right? Is it? And there's a series of questions, and the very last question says, "What's the range?" That's to say, what's the horizontal displacement? How far does the cannonball go? Now, to answer that question, you have to answer a bunch of intermediary questions first. Oh, and that's what all these are. So as long as you're getting these right one at a time, blah blah blah, they'll lead straight into the next one. Okay, and we've solved a few problems in class that look pretty similar to this, right? In fact, that looks a lot like maybe the questions on the right side of this page, right? They look a lot like that, especially like these do. I bet they do. So it looks like that. All right. Any questions about take-home quiz? Any questions about anything at all before we flip over to Kahoot? Kahoot. All right, and then actually a couple things I want to mention for Kahoot. One is that somebody turned in a linear motion quiz with no name. It was turned in the day I had a sub, so I don't even know what class it's from. Just how the papers were. I was trying to do my detective investigating, but I have no idea if it's even from this class. But double check your focus. Make sure that all your assignments are turned in, and if you think you turned in something like the linear motion quiz and is showing like if there's a blank there, like no grade, if it says NTI, like not turned in, yeah, just make sure you got all your stuff in. And this is somebody's, but it doesn't have a name. So anyway, you guys know that's floating around. Double check, focus, make sure all your stuff is in, because grades are closing, well, Monday.
I was absolutely connected.
All right. Yeah. And if you got it, linear motion quiz, get that in. Yeah. So I'll get there. I will get the grade in for you. For projectiles.
The quiz that you should do.
Yeah, that's projectiles. This is linear motion. Linear motion quiz. All right. We do linear motion quiz honors. There you go.
So I just need this paper and the quiz.
Yeah.
This one.
Okay. Yeah, that's something. All right. You are good. All right. So you guys ready for Kahoot? All right. So switch my screen over. All right. And all right. And if you did want to follow along with these printed questions, remember you guys have them on the back side of your homework. So this is right there for you. All right, guys ready to get going?
Wait.
Almost. All right, so if you're about to hop in, you guys see that 6-digit pin? That'll show up at the bottom of the screen. So you can hop in a minute late if you need to. All right, and here we go. A vector, for example, acceleration, is a quantity that has both what and what. Yeah, magnitude and also a direction. Right? Remember, scalar quantities only have a magnitude. That's like a number you can put into a calculator. For example, my mass is 5 kilograms is a scalar that doesn't have a spatial direction. But acceleration, for example, acceleration due to gravity, that's always down, isn't it? Right? Or if you push with a certain force, like there's some direction, right? Or if you're driving in a car, you might be going forward or backward. Yeah, so those are vector quantities if it has a direction attached to it. And the magnitude is the number you can type into a calculator. Okay, guys got that? Right. You might say like velocity is 5 meters per second north. 5 meters per second would be the magnitude. North would be the direction. All right, we got Bad at Psychics, Max, Logan, Ryan, and Fred, also known as Fred. A scalar, for example, mass, only has magnitude, right? So for example, if you say mass is 5 kilograms, 5 kilograms is the magnitude, like how much? But yeah, mass does not have a spatial direction. Right? Now you might be thinking about what about weight? But weight is a force. Weight is a gravity force that pulls down. And now forces are vectors, right? Because like weight could be down, would be a vector. It's a direction. All right, bad at psychics, but good at Kahoot, still in the lead. Suppose a plane can fly 100 kilometers an hour relative to surrounding air, and it also gets a boost from a 60 kilometer per hour tailwind. What is the speed relative to the ground? There you go, 160. Right. So the plane relative to the air is 100. The air relative to the ground, maybe that entire air mass is moving, like wind, is 60. Right. You know what I did here? Let me draw this out for you guys. Let's draw this out. Okay. So I got myself a plane. Okay. See, this plane is directed straight north, for example. Let's say 100 kilometers per hour. Right. And then no, that would be the plane relative to the surrounding air, right? Like its jet engines are pushing against the air, and that's like how fast it can go. But then what if the entire air mass is moving relative to the ground? Another 60 kilometers per hour. Right? See how I connected these tip to tail? You guys see tip to tail? Tip to tail. Vector connection, right? You guys remember that? Right. Geometric addition of vectors. Then you go from the tail of the first guy to the tip of the last one. Here there's only 2 vectors. Okay. You get the resultant vector. You guys remember the resultant vector? If you didn't see it before, but you see it now that the magnitude of the resultant is 160 kilometers per hour. Get that? So we have the plane relative to the surrounding air. We have the entire air mass relative to the ground. So put those together, you get the plane relative to the ground. That's its ground speed. You guys see it? Yep. Switch back over. How we doing on the scoreboard? We got Bad at Psychics, Max in second, Ryan, Logan, and Natalia rounding out top 5. What is the resultant of a 3-unit vector and a 4-unit vector at right angles to each other? Ooh, 5 units. All right, so this one I definitely got to draw out. Right. So why is the resultant 5 units? Well, how about this? Let's say I got this object, middle of my page. Let's do force vectors. I know we're quite forced yet, but you guys get the idea. What if I'm pushing up with 4 units and pushing to the right with 3 units? Right? Is this thing getting can move up and to the right? So probably a little bit more up than to the right because I'm pushing up a little bit harder, right? Let me draw that out. Suppose I was pushing up with like 4 newtons of force. And then at the same time pushing to the right with 3 newtons of force. Oh, look at that. It's a tip to tail vector connection. You guys see tip to tail? Tip to tail. Vector connection right there. Right? And then if you go from the tail of the first one to the tip of the last one, just like with the plane, except now it's in 2 dimensions. Ah, if you didn't see it before, I bet you see it now. See how it's gonna go up and to the right? In fact, this is set up a what triangle? 3, 4, 5, right? So this must be 5 newtons, like a net force, right? Now, in general, when you get that from Pythagorean theorem, so the square root of 3 squared plus 4 squared, number of newtons, you guys can do that, right? And of course, that comes out to 5. Okay. Right, so let's see that again. So if I push it with 4 newtons and I push to the right with 3 newtons, it's gonna the net force on this thing is 5 newtons, and the direction is up and to the right. Let's go one step deeper. Could you guys solve for theta? Inverse tan 3 on 4. You guys could solve for that, right? It should come out to like 37 degrees because it's a 3, 4, 5 right triangle. All right, back over to Kahoot. Bad at psychic, still in the lead. Ryan, Max, somebody calling Jenny, and Addy. Plane flying into a headwind loses ground speed, and plane with a tailwind gets a boost. What about a 90-degree crosswind? Ooh, overall ground speed increases? So 3 of you guys are saying that. That's the answer. Now, why is that the answer? Well, let's flip back over and take a look.
Because even if speed is not increasing the direction you're already going, it's increasing total.
Yeah, right. Yeah. In fact, the answer is already here. You make a small modification. All I have to do is draw a little plane right here. Instead of newtons, say meters per second. Meters per second. Meters per second. Meters per second. Right. Like if the plane itself is flying north at 4 meters per second, and the entire air mass is moving to the right at 3 meters per second, you guys see the plane itself would move kind of northeastish, right? And its shadow would move across the ground at 5 meters per second, right? And 5 is greater than 4, right? That's it. Right, so the plane's overall speed relative to the ground is faster. Yeah. Now it's still pointed straight north. It's still trying to go straight north. Be blown off course. Yeah. It's got plane relative to the air relative to the ground, then the plane relative to the ground. Got Bad at Psychics, got Ryan on fire, Max, Colin, Jenny, and Addy. Ball is thrown into the air, some angle at the top of the ball's path. Its velocity is what? Entirely horizontal. Okay, let's take a look at why that would be. Right. Ball thrown into the air at some angle. Does this look pretty familiar? Right? Remember, here, so here's the path it goes. Right? Here's its individual velocity vectors. See, it's kind of slowing down on the way up and speeding up on the way down. Right? So that's why the arrows get shorter on the way up and then longer on the way down. Okay. But then if you break this into components, see those blue components? Right up, right up, right up, strictly right, right down, right down, right down, right, right. And you guys see the horizontal component stays the same all the way across. In fact, at the very top, it's only horizontal, and that was the question, right? The top, it's only moving horizontally, right? You know what, while I got this up, let's do this. Suppose the upward component is like 30 meters per second. After 1 second, how fast? Upward. 20, and then 10, and then 0, and then 10 down, and then 20 meters per second down, and then 30 meters per second down. Right, now that's just strictly vertical. Okay. Okay. You guys good there? Right, remember how that's working? All right. Back over to Kahoot. Bad at Psychics, Ryan, Colin, Jenny, Max, and Fred, also known as Fred, back on the board. Ball is thrown into the air, some angle. In the first second, it moves 5 meters horizontally. How far horizontally in the next second? Yeah, another 5 meters, right? Because remember, horizontal component of velocity does not change, right? There's nothing accelerating it horizontally. So it keeps going 5 meters per second to the right. So every second moves another 5 meters, right? You guys got that? Any questions about that? Right, you guys good? All right, yeah, thank you. Projectile maintains horizontal component of velocity because yeah, because it's not acted on by any horizontal forces. Now, there's still a vertical force. The vertical force is its own weight, which is gravity, but that only affects its vertical motion, right? Horizontally, it just keeps doing what it's doing all the way across. Yeah, let me flip the screen over so you guys can see this diagram again, right? Okay. So this ball, see, slowing down a little bit on the way up and speeding up a little bit on the way down. But the way we're analyzing it is to say what's going on strictly horizontally and strictly vertically, right? Now, remember, vertically, it is changing 10 meters per second every passing second, right? But horizontally, it stays the same all the way across because gravity doesn't pull horizontally. And we've been ignoring air drag. We keep doing that. So yeah, it just same speed horizontally all the way across the field. Back to Kahoot. Adding hop in the top 5, Fred on fire, bad at psychic, still in the lead. What part of a path does projectile have minimum speed? Yeah, at the very top of his path. Remember, it was like slowing down on the way up and then speeding up on the way down. Okay, and so at the very top of his path, minimum speed. Okay, let me flip my screen real fast. Just take a glance at this real fast. You see it at the very top, it's moving the slowest it ever moves, right? Okay. All right, so back over here. Next. Same leaders. I'm good. More points. A cannon fires cannonball horizontally off a cliff at 30 meters per second. How far horizontally does the cannonball move in 1 second? Yeah, 30 meters, right? It's going 30 meters per second across. So every second goes across another 30 meters, right? Right, you guys good? All right, more points. Look, it's got 6 players on fire. Oh, yeah. Students on fire. It's easier to hit a home run in Denver, Colorado than in Miami, Florida, because it's something that we've been ignoring in this class. All right, and you guys got it. Yeah, thin atmosphere. You guys ever who's ever visited Denver, Colorado up there? Oh, wow, a bunch of you guys. Wow. You guys ever try to run around a mile high?
Oh,
Yeah, get winded really fast. I remember I did. So yeah, air's really thin up there, so there's not as much air drag. Right now, for this class, we ignore air drag anyway in our calculations. But yeah, in the real world, there's a lot more air drag down here at sea level than up in the mountains, and that does make a difference. Much easier to hit a home run up in Colorado. Ooh, Natalia hopping in top 5. Got it, sidekicks, still the lead. Oh, in the absence of air resistance, what's the optimal angle to throw a ball the furthest distance? Showed you guys this yesterday. Yeah, 45 degrees, right? You guys remember yesterday I broke out a packet with a proof in it. Said, so like what angle would you have to throw it at to get the furthest distance? Right. See, if it's shallower than that, it's not in the air for very much time. If it's steeper than that, then it doesn't have very much horizontal component of velocity. So the trade-off, yeah, it's at 45-degree angle. Right, if you're in a ball throwing contest with your friends, throw it at 45 degrees. All right, got more points. Cannonball launched at 30 meters per second over a flat terrain. In the absence of air resistance, it will land at a speed of what? Yeah, 30 meters per second. Now, this could be a symmetry question. It's probably the easiest way to answer this. Okay. We'll just real fast. Right, so here's one way. I'm going to simplify some numbers just to get you guys the big idea. Suppose you launch this at like 30 meters per second, right? And then it's going to slow down a little bit. So, right. So maybe it's kind of like 25 and then 20 and then 15 meters per second. And then it starts to pick up again, right? Like, so 20, 25, and then 30. Right? The numbers don't work out exactly like that, but you guys get the idea. Slowing down a little bit on the way up and then speeding up on the way down. Okay. All right. And then at equal elevations, you should have equal speeds. Right, so symmetry. Oh yeah, more points. More students on fire. Oh yeah. A projectile launched horizontally hits the ground in 1 second. If it had been launched at a faster speed, how happens to the hang time? Yeah, would stay the same. Now, why would it stay the same? All right, so let me flip the screen over and give you guys a picture. Right. So if you launch the ball horizontally, it's supposed to hit the ground in like 1 second. Oh, I've got my own side question. Guys, if it takes 1 second to fall down this cliff, who remembers what the height of the cliff is? 1 second to fall. 5 meters. Yeah, 5 meters. You guys remember 1/2 GT squared? Right, and then so if you just drop the ball from rest, in 1 second it falls 5 meters, right? Which is on that poster over there on that wall, right? But what if you launch it to the side? Doesn't it have the exact same vertical motion? Right? Right. You guys remember Paul Hewitt did that experiment, right? He had a couple balls. Yeah, one went straight down, one went side. They hit the floor at the same time. You guys remember that? Right. Right. So remember, vertical and horizontal motion are independent of each other. You know what? I will give you guys a caveat, which is going to pop up here pretty soon. This is ignoring the curvature of the Earth. So actually, one of those other answers that was marked wrong on Kahoot could have been right if you consider that if you blast fast enough, let's say about 8,000 meters per second, you might actually into orbital velocity. We haven't quite got there yet. That's a future topic in this class, but it's one of our simplifications, right? So we're ignoring air drag, and we're also ignoring the curvature of the Earth at this point in the class. Okay. But there's an orbital question somewhere in here. Ooh, Bandit Psychics is on fire. Object thrown 30 meters per second off the top of a cliff horizontally. Okay. What is its acceleration and free fall? Acceleration and free fall. On Earth, what is acceleration? Always in free fall. Yeah, there you go. 10 meters per second squared downward. Okay. Doesn't matter how fast it's going, which direction it's going. Yeah, it's always if it's in free fall. If the only force on it is its own weight, then that is true. Okay. Of course, we're ignoring air drag. That also goes into making that true, is to ignore air drag. Ooh, rounds on fire, bad at psychic, still in the lead. Neglecting air drag, which we always do. At what point is acceleration greatest for a ball thrown straight upward? Yeah, the same everywhere in free fall. So all those options are some point during its free fall. So once the ball has left your hand, then it's in free fall, and it's always accelerating down at 10 meters per second squared, while it's moving up, while it's moving down at its peak, right? Now, if there was an option on there that said like during the motion of throwing it, then that would have been the answer. But yeah, while it's in free fall, yeah, it's only 10 meters per second squared downward, which is the same everywhere in free fall. All right, that psychic's on fire. Suppose you could jump 1 meter vertically. If you were on a skateboard moving 50 meters per second to the right, now you can jump what?
Register my tap.
Sorry, it's getting kind of glitchy.
Let me tap.
Yeah, sorry. But your vertical motion would be the same, right? So it doesn't matter how fast you're moving to the right. If you can jump 1 meter, you can jump 1 meter, regardless of your horizontal motion, right? Is that okay? You guys got that? All right. Same leaders. We got. Oh, Streak at 17. Wait, did somebody have a perfect game going? Ooh, somebody does have a perfect game going. Ooh. When in orbit, a satellite such as a space shuttle. Got a little tricky question here. You guys get this. All right, most got that. All right, so we haven't exactly talked about this yet. This is a future topic a few weeks from now. But space shuttle. Now, if you're in low Earth orbit, in the big scheme of things, compared to the radius of the Earth, proportional to that radius size, you actually aren't that far up there. It's about 400 kilometers up. Low Earth orbit, you actually get about 90% of the gravity you do down here at the surface. So if you built a tower that was that tall, went all the way up to low Earth orbit, right, and went to the top of that tower, you'd have about 90% of your weight that you do down here on the surface of the Earth, right? You're getting further from Earth, so the gravity pulls not as much, but it doesn't really change that much. Right? You might just barely be able to tell the difference. Okay? But you look out the window, you might see a space shuttle fly by, see some astronauts floating around. They appear to be gravity free. How is that possible? Right? How can you have 90% of your weight, but you look out the window, they look like free fall? Yeah.
Relative, your view of them being in free fall is relative to the spaceship, which is also in free fall.
Yeah, right. Yeah, spaceships in free fall. Yeah, and that's the catch, right? So yeah, this one, true. Yeah, you have to consider that you'd be going so fast to the side in the space shuttle, you'd actually be falling with the curvature of the Earth, right? So if you go 8,000 meters per second horizontally, then you fall 5 meters in 1 second, but the Earth also curves exactly that much also, right? So there you go. So there's some free fall. All right. I don't know if I've ever seen a perfect game, but Bad at Psychics is 2 questions away. The ball thrown straight up at 20 meters per second will return to the ground. Yeah, 20 meters per second, right? So if you throw it straight, oh yeah, so almost everybody got that, right? So let's do second by second. So 1 second after you throw it, it's going 10 meters per second up. Then the next second's going 0 meters per second up. Then the next second's coming 10 meters per second down. And then final second after, so 4 seconds, it's in the air. All right, so crash speed is the same as you threw it, based on symmetry. There you go. All right, Pratt, your shit's back in the game. All right, we got Natalia, Fred, Colin, Jenny, Ryan, and Bad at Psychics. Going into the last question, number 20. A cannon with a barrel velocity of 120 meters per second launches the ball horizontally from the top of the cliff. How far will the ball fall in 3 seconds? How far will the ball fall? 3 seconds. Guys, would this be the exact same physics if you just reach out and drop the ball? The same vertical motion? 2 winners! What? Okay. Or well, we got just enough class time I can talk about this. Alright. Here. So you blast it 120 meters per second. The question was, how far does the ball fall in 3 seconds? Guys, if you just drop the ball, how far would it fall in 3 seconds?
45.
45 meters. In fact, that actually exactly matches this clip, doesn't it? Right? You like hit the ground. Hey, what about the ball that you blasted really fast to the side? Does that fall the same vertical distance in 3 seconds?
Yeah.
Yes, it does, which is 45 meters. Remember, it's horizontal motion and vertical motion are independent of each other. Okay. So the exact same as if you just dropped the ball. Okay. Has nothing to do with the blast speed, you know, as long as it doesn't like near orbital velocity or something crazy like that. Okay. All right, we're about to find out if Bad at Psychics got a perfect game, which I think might be the first one I've ever seen. But time will tell. With the bronze, Ryan, 17 out of 20. With the silver, Colin, Jenny. And with the gold, oh, so close, so close. Bad at Psychics. Runners up, Fred, also known as Fred, and Natalia. All right, very good, very nice. You guys did a really good job on that. All right, well, we got about a minute to the bell, so I guess I'll go ahead and call that a wrap on the video. Here we go.